Okay. In this class, we are going to discuss about domains and paths. Go for the next slide. So here, this is the introduction related to the domain. So in the subject called mathematics, domain is a set of possible values which are independent variables or the variables of a function. So if it is a set of variables which are independent to each other, we can say that one as a domain in the term mathematics. So we have already listened in mathematics that it in a set of values which are in each other, we can say that one as a domain. But in the term software testing, what is called a domain? Here, a domain is a thing related to the programs as a input data classifiers. Here, the domain testing attempts to determine whether the classification is correct or not, whether the whatever the inputs that we are going to giving there, we are having some set of inputs there. So the program which we are using as input data classifiers, so at the time of domain testing, it attempts to determine whether this classification is correct or not. So whenever you are going to perform the domain testing, it can be based upon some specifications or the equivalent implementation of an information. Here, if the domain is if domain testing is based upon the specifications, we can say it as a functional test technique. So suppose if it is based upon some specification, like we have to use some integer values, or especially we have to use some character values, or especially we have to use some type of floating type of variables. So at that some specifications we need. So at that time we need some set of values, but that set of values are not dependent; those are independent to each other. It is if the domain in that time, if domain testing is based upon some type of specifications, then it is a functional test technique. So if domain testing is based upon the implementation details, it is a structural test technique. So for example, if you are doing domain testing, when you check extreme values of an input variables, all the inputs to a program can be considered as if they are numbers. For example, if you have taken a character string, it can be treated as a number. If you are going to concatenate that bits, and if you are looking at them as if they are a binary integer, see, if you have taken some character as a input, so if you are treating that as a number, by we have to concatenate, means we have to combine that bits, and we have to look at them as if they were a binary integer. See, we are having some trouble that computer does not understand the type of alphabets. That alphabet should be converted into a some binary digit. So it has to concatenate the type of binary digits. So this is the view in a domain testing, which is why its strategy has a mathematical flavor. So when you have some doubt like that, so we are performing testing, then why a mathematical subject has came into picture, means whenever you are going to perform some testing here, suppose whether it is having whether you are going to take some set of values there, but here in some set of values also, whenever you are going to perform some type of testing there, so if it is some, if you are treating that as a number by concatenating that bits and looking at them as if they were a binary integer. So we have already known about the binary integer in the form of zeros and ones. So even if it is a character value, that should be converted into a binary value. That why? Because the machine understands only that type of language. So at this particular time, they need to solve this particular type of integers. To solve that particular type of numbers, we have to go for the concept called mathematics. So we are using this particular rules, okay, that related to the domains. So this is the view of a domain testing, with which is why this strategy has a mathematical flavor. From this we can know that why we are going for this mathematical statements. So this is the case. This is the following schematic representation of a domain testing. Whenever you are having some performing domain testing, this is the case that we are going to. This is how we are going to represent there. This is the diagrammatic representation. Suppose here this is the input that we are giving here. You are going to, first of all, you have to classify that whether it is an integer variable, a classification. Based upon this classification itself, we are going to categorize that one. We have whatever the input that you have given, that you have to classify here. From this classification, we have to perform different cases. We have already know that we are taking this one in different cases, case 1, case 2, case 3, just like up to case n. How many cases that we need as per our program. So up to n cases we have taken, and after execution we will combine all these particular kind of cases, and it will produce some particular it will produce this one called output. Okay, this is a semantic representation of a domain testing. So how we are going to perform a domain testing, here we have represented it in a diagrammatical way. So if you have gone for the next slide, see, before whatever you are doing, before doing whatever it does, a routine must classify this type of input, and we have to set it we have to move it into the right path. Whatever it is, why you have to choose it for the right path? Because whether if you are taking some kind of variables, but you are going for the other kind of variables, that may raise ambiguity. So in case of without raising any ambiguity, if we have done some classification, definitely we are going to we definitely will success in this particular kind of operation. So before doing it one, whatever before we are doing, it does a routine. It must be classified the input, and it should be moving in the right path. Moving in the right path is also a very important thing in this particular kind of testing. So if it is a valid input, suppose if you are giving a too long input, just a special processing called reject. So based upon this classification, if they might have given a wrong input, or if they have given a too long input, for example, if you have chosen this example, if they have taken this if the bit is too long, the value is too big, then definitely automatically it will be rejected. How automatically it will be rejected? Based upon the classification. If by the beginning itself, if you have done this step of classification, then automatically it will be rejected. So the input then passes to this hyperlogical subroutine rather than calculations. Suppose in whatever the domain testing we are performing, in domain testing we focus on the classification aspect of the routine rather than some classifications. See, in domain testing, first of all we have to focus on the classification aspect of the routine. Why? Because without classification we can't, we doesn't know how we can what is the what kind of input it is. So in domain testing, you have to mainly focus on the classification aspect of a routine rather than all this classification. So if it is a structural knowledge, whatever we are needing, it is a structural knowledge, and it should be need for this model. Only a consistent complete specification input values for the each case. See, some consistent specific input values we should need in some particular kinds of cases. So we can infer that for the each case there must be at least one path to process that case. So we have to define some paths. Paths means what? In the previous class itself we have discussed the way that we have chosen for the particular kind of program from one statement to another statement, how the process is going. For that, to go from one statement to the another statement, we need some path to flow the transaction. So for that particular path, we must process that case should be at least one. From this we can say that before doing whatever it does, a routine must classify the input and set it moving on the right path. And the next one is an invalid input is just a special processing case. We can call it as a whether it is too big, we can definitely reject. And next one is the input then passes to the hypothetical subroutine rather than the calculations. The domain testing we focus on the calculation aspect of the routine rather than one calculations. So the structural knowledge is needed this model. Structural knowledge needed for this model only consistent complete specification of the input values for the each case. We can infer that for each case there must be at least one path to process that particular case. So from this we can say that before going for the testing, the classification is a major aspect. Okay. So from this we can say about the domain, that a domain is a set. An input domain should be a set. For example, if the source language supports some definitions, for example, if you have taken Pascal language, a set of set types, and C enumerated types. See, enum is a data type that we have used. In the Pascal, we have set types. Just like that, we are having some data types to classify that. So, this is a different language that we are choosing here. And next one is the less testing is needed because the compiler does much it for the us. Whatever the compiler that is doing, if it is doing better thing, or if it is not a, so if it is a small thing also, we have to show our level best. So less testing is needed. Before doing this testing, we have to practice the less testing is needed because the compiler does much it for us. So domain testing does not work well with arbitrary discrete set of data objects. So domain for a free program corresponds to a set numbers defined over a input vector. So from this we can say it as a domain as a set. See, here an input, whatever the input, suppose 1 2 3 4 5 6, or suppose 1, if you have given all the integers as an input, so we have taken that all the integers as a subset of values, so we can say it as an integer set. If you have taken the float values, that just like 3.4, 3.5, 6.8, just like that, if you have taken those 3.4, 6.8, 6.9, just like 6.9, just if you have taken those sets, we have to take this as a float input values. Just like that, we are going to classify the set of values. So we can, from this we can say that the input of the domain is a set. Okay. Here, the domain testing does not work well with the arbitrary discrete set of data objects, and domain for a free loop-free program correspond to a set numbers defined over the input vector. So, in domain testing, predicates are assumed to be interpreted in terms of the input vector variables. So, if the domain testing is applied for a structure, then the predicate interpretation must be, interpretation means what? If we have to perform the interpretation, must be based upon the actual paths through the routine, that is based upon the implementation of the control flow graph. See, we have drawn the flow graphs and control flow graphs. Before performing the testing, we have to check this control flow graph once, whether it is the conversely, if the domain is applied to specifications or not, or the interpretation is based upon the specified data flow graph for a routine, or but usually it is the nature of the specifications and no interpretation is needed because the domains are specified directly. So for every domain, there is at least one path through the routine. So from this we can say that we have to choose at least one. We must have different types of paths and different types of programmings we must be performed there. So the domains are defined as per the boundaries. There are more than one path if the domain consists of the disconnected parts, or connected paths we are having if the domain is defined by the union of two or more domains. So the domains that are the domains define their boundaries. Domain boundaries are also where most domain bugs occur. Okay. See, this is a continuation for that. So for every boundary, there is at least one predicate that specifies what the numbers that belongs to that domain and what the numbers does not belong to that domain. So for example, if in the statement, if x greater than 0, then alpha, if x greater than 0, then alpha else beta. Suppose if alpha and beta are separate different types of set, so we know that the number should be greater than 0 or belong to alpha processing domains, while 0 and small numbers belong to the beta domains. So a domain may have one or more boundaries no matter how many variables define it. For example, if the predicate is x2 plus y2 less than 16, the domain is inside of the circle if the radius 4 about the origin. So similarly, we could define the spherical domain with one boundary, but in three variables. So here the domains are usually defined by the many boundary segments, and therefore from this we can say that many predicates. Predicates means what? How we are going to guess that predicate. How we are going to guess that how the testing is going to perform. That is set of interpreted predicates. It should be traversed. So many times we are going to perform on one path. That is, suppose if we are going to if it is a path predicate expression, we are going to perform so many types of traversals that defines the domain boundaries. So from this we can say that a domain may have one or more boundaries, no matter how many variables define it. We have taken this example also. If x2 plus y2 is less than 16, we have to take in the input values that should be of the value x2 and y2. If we have taken that value, we have to categorize that classification whether the value of x2 and y2 is related to the integer values or some different types of variables. So from this we can say that if the particular domain is inside within the or if it is circle of radius 4 about the origin. Similarly, we could define a spherical domain also with one boundary in three variables. So from this we can say that the domains are usually defined by many boundary segments, and therefore by the many predicates. That is a set of interpreted predicates or traversed to that one path. From this we can say that it is having no matter how many variables will define it. Okay. See, if it is a closure, in mathematics we have defined the term closure also. If it is a closure, a domain property is closed with respect to a domain if the points on the boundary belong to the admin. So if the boundary points belong to some other domain, see, we are having some domains, some set of values here. That is integer set of values, floating set of values, scatter set of values, just like that. If two domains are not related to each other, then what we are going to perform? Let us see. So if the domain boundary is closed with respect to the other domain, if the points on the boundary belongs to the domain. So if the boundary points belong to some other domain, then the boundary is said to be open. Okay. Then this in the following the figure that we are going to show, that shows the three situations for a one dimensional domain. That is the domain defined over a one input variable. So if we have defined one input variable, we can call it as a x. So the importance of the domain closure is incorrect. The closure bugs are frequent domain bugs. For example, x greater than or equal to 0 when x greater than 0 was intended. So let us see this following figure. See, this one as both domains. See, this is domain 1, this is domain 2, and this is domain 3. Here both sides for this domain 2 are closed. Okay. If you have observed this particular type of domains, here this is domain 2, the domain 1, domain 2, and domain 3. For this domain 2, one side is closed and one side is open. Okay. Here if you observe this domain, here both sides the domains are opened. Okay. From minimum to maximum we have to classify this domain. That is from minimum to maximum we have defined some set of variables here. So please observe this figure once again. Here in these three domains, this is the domain that we are going to process. So for this domain, the both sides are closed. From minimum to maximum we are going to write the set of values. Here the both sides are closed. Next one, if you have observed this set of variables, if you have observed this one, here also we have written from minimum to maximum. Here from the end side we have opened the domain. Okay. Here both sides, from beginning side and ending side of the domain 2, we have opened this domain. So this figure explains about open and closed domains. See, if you have gone through about the domain dimensionality, here each and every input variable adds one dimension to the domain. Okay, if it is a one dimension, you have to check whether it is going to do for the one dimension or another dimension. You have to check. Here one variable defines domain on a number line. So two variables define the planar domains. If it is a three variable, it will define the solid domains. So every new predicate slices through previously defined the domains and cuts them into the half. So every boundary slices through the input vector space with dimensionality which is less than the dimensionality of the space. Thus the planes are cut by lines and points, volumes by planes. Lines and points are n spaces by the hyperplane. So here, if you are coming for the domain dimensionality, according to that, if you are going to calculate the dimensions of that particular domain, these are the characteristics that we are going to follow. Here, the each input variable adds one dimension to the domain. One variable defines domain on the number line. Two variable define planar domains, and three variable defines. So if it is a three variable domain, it will define the solid domains. So if your domain set containing only one variable, it will define a domain on a number line. So if it is two variable, it define a planar domains. So if it is a three variable, it will define the solid domains. This is how we are going to categorize. So every new predicator slices through previously defined domains and cuts them into half. So every boundary slices through the input vector space with dimensionality which is less than the dimensionality of the space. So thus the planes are cut by the lines and points, volumes by the planes, lines and points by the n spaces hyperplanes. See then how we are going to assume the bug in this particular kind of domain. So the bug assumption for the domain testing is that processing is okay, but the domain definition is wrong. If the domain definition is wrong, then definitely at that particular time the bug we are having a chance to erase a bug. So an incorrectly implemented domain means that the boundaries are wrong, which may in turn mean that the control flow predicates are wrong. So at some particular kind of at some particular time it may have the chance that the control flow predicates also wrong. So here also we are having the chance to erase the bug. So here many different bugs can result in the domain errors. See some of them are, see at that particular what are the domain errors that we are going to get here. See, double zero representation. See in computers or languages that have a distinct positive or negative zero, suppose taken double zero representation, they may have the chance to get the error. So if it is a floating point 0, so at that particular point, floating point, if you have 0, if you have implemented the 0 multiple times, see a floating point number can equal to 0 only if the previous definition of that number set it to 0. If you have set that particular point to 0, so for at that if you have defined that condition, at this particular type of condition itself it will be equal to 0, otherwise it won't be equal to 0. Suppose if it is subtracted from itself or multiplied by 0, suppose if you have taken 4.6, if you have subtracted 4.6 with 4.6, definitely it will that value will become 0. Okay, or if you have multiplied that 4.6 with 0, then the value will become 0. So the floating point 0 check to be done against the ellipson value. So we have to check whether if we have check whether that input value that we have subtracting should be equal to that floating point or not, or the input value that you are multiplying with that value is equal to 0 or not. These are the two cases in case of the floating point 0 check. Next one, contradictory domains. So an implemented domain can never be ambiguous or contradictory. So whatever the domain that we are going to implement, that should not be ambiguous. Ambiguous means what? Confusion. We should not have the confusion whenever you are going to implement something. we should not be we should be confident. We should not in the confusion mode. So it should be a contradictory but specified in the domain can. A contradictory domain specification means that at least two supposedly distinct domains should be overlapped. So these are the different chances that that may domain, that a chance that the domain can have a. Okay. So this is about, if it is an ambiguous domain, the ambiguous domain means that the union of the domain is incomplete, so that there is a different missing domains or holes in the specified domains. And if you are not specifying what happens to the points on the domain boundary is a common ambiguity. So it is a over specified domains. If it is over specified domain, the domain can be overloaded with so many conditions. That is, the result is a null domain. Another way to put is to say that the domain path is unachievable. So the errors caused in the around the boundary of the domain, for example, the boundary closure bug, shifted, titled, or missing of extra boundary. If it is a closure reversal, if it is a then it is a common bug. The predicates is defined in terms of if it is greater than or equal to if it is greater than or equal to logic, or less than or equal to logic, or greater than logic, or less than logic, then we can say the topic comes under the closure reversal topic. So then what is a fault logic? Then the compound predicates, especially that are subjected to the logic transformations. If it is some kinds of logical transformations like logical errors and improper simplifications, then at that particular time the predicates define the domain boundaries, and all kinds of domain bugs can be result from the faulty logic manipulations.